Hello, everyone. We will go ahead and wait a few moments to see what the final tally for attendees will be. But in the meantime, if you are so inclined, feel free to let us know where you're calling in from in the chat. I'm in Finland, and our presenter today, Sebastian Insausti, is. Where are you, Sebastian? Are you in Vancouver?
Yes, I'm in Vancouver right now.
Yeah. So we're almost as far as we can get away from one another.
Hmm.
Hey, hey, Vinay. That is our fearless leader, CEO, co-founder. We'll wait a few more minutes, or not minutes, but moments. Okay. Let's go ahead and get this show on the road. All right. So again, hello and welcome everyone to today's presentation. My name is Kyle Bazell. I am the Director of Marketing here at Severalnines. And with me today, it looks like someone has raised their hand. Just a moment. Yes, Vlad?
No, I'm sorry. This was just a mistake.
Okay.
Sorry.
Vlad just saying hi. Um, just a moment. All right. And with me today is Sebastian Insausti, whom I will introduce in a few moments. He will be the one giving us our treatment on PostgreSQL or Postgres bidirectional replication. But before we get started, let's go over some housekeeping items. Just two. First and foremost, standard presentation webinar format includes the presentation itself, a short demo, Q&A. We will be running that Q&A in the same order that is listed on this slide. But if you have a question that pops up in your head during the presentation or the demo, feel free to just plug it into the Q&A section on your screen, and we will get to it during that portion of the webinar. We will also be doing two short polls just to get an idea of where everyone is in terms of Postgres, Postgres BDR, and even cluster control. You know, what your familiarity is, what your comfort is, what your use of it is, if at all. And with that, let's run into the agenda. Top to bottom, what it is, what it isn't, what it solves for, its pros and cons, when to use it, likewise not use it, even its implementation requirements and the process for manual implementation. Sebastian will also be going over what's in store for PG 18. If I remember correctly, I think PG BDR became a feature in 16. Then they did a few feature enhancements in 17, the latest release, and they have some plans to make it ready for prime time, hopefully in 18. So for instance, dealing with things like DDL, which we'll parse in a little greater detail in this discussion. And naturally, we're going to look at cluster control because the more capable a feature is, typically the more complex it is to deal with in from an operational perspective. And we're going to give you some insight into how cluster control can simplify that for you, whether you're running your operations on-prem in a cloud or some hybrid setup. So now that we know the what, let's look at the who and why. Won't spend so much time on the who, not the right format, and I don't think we have enough time to delve into the complexities of who Sebastian is, but the why. Why should you be listening to him today? He is one of 7 senior support engineers here. These guys are the backbone of everything we do at Severalnines. They're probably one of the reasons outside of the product why our users love us. And by extension, I love them. Um, He is also our in-house Postgres expert. So when he's not helping users troubleshoot issues, he is producing content for us or he's answering Postgres related questions. So to the content piece, if you haven't already, go to severalnines.com when you get a chance, hover over resources, go to white papers, and you'll see his latest white paper on day 2 ops for Postgres. Nice thorough treatment of what you need to consider when you're looking into day 2 ops for Postgres. It's ungated, so you can go ahead and download it at will, or you can just read it on page if you want. And otherwise, 18 years of experience. He's got the whole alphabet soup of disciplines: DBA, SRE, DevOps, sys, network admin. You name it, he's done it. So that's why you're listening to him and not me. I can barely say Postgres bidirectional replication, but I assume most people can't say that 5 times fast. So from here on out, if you hear from me, I will be saying PG BDR. And I hope you understand. And last but not least, before we kick this off and hand it over to him, let's take our pulse poll. I'm going to launch it now. So it only take about 15, 20 seconds. If you don't see it, it'll probably be in the other screen. But yeah, I'll give everyone about 15, 20 seconds. All right, it looks like some people are finding it now, so we'll extend it a little longer. 5 of 36 have participated, so we have a pretty good crowd right now. Okay. Countdown for everyone. 10, 9, 8, 7, 6, 5, 4, 3, 2, and 1. All right, guys and gals, thank you for participating. 20 responses. All right. So without further ado, let's go ahead and get into it. You are now in control, Sebastian.
Thank you. Thank you for the introduction. Let me. Mm, okay. Can you see the slides?
Yes, I can.
Okay. So yeah, let's see first what Postgres bidirectional replication is and what is not, and also other concepts to understand how it works and how to implement it in a correct way. Yeah, but first let's see what logical and stream replication in Postgres is, um, because this is based on these concepts actually. So it is good to refresh them. Logical replication is actually a method or a model of replicating tables and data changes between databases, like inside updates. And it's based on a publish and subscribe model. And it allows replication of specific tables, even across different Postgres versions. And you don't need to replicate all the data. You can choose what to replicate. And this is for logical replication. For streaming replication, is different because it copies or replicate the entire database by streaming low-level changes from a primary node to a one or more than one standby nodes. And it uses binary world data, write ahead logs files. It also it creates exact copies of the primary. It's a physical replication. And here you can't choose what to replicate. It will replicate everything. And in this model, in this replication type, the standby node is read-only unless you promote it to primary, but the standby node is always read-only. And here, just to mention the default workflow is basically for logical replication. You have the publisher that creates a publication, a set of tables. The subscriber creates a subscription and connects to the publisher, streams changes, and the subscriber applies these changes. That is the workflow for logical replication. For streamer replication is a little bit different because, well, primary writes changes to the world files. The standby server connects and stream the worlds. The standby applies worlds records to stay synchronized with the primary node. These are the default workflows. Of course, there are more processes and concepts involved, but just to get the idea about how these models or technologies work, because we will need them, we will need to combine them to implement this solution. So that is why we are mentioning them here. So now, in this context that we mentioned, a bidirectional replication refers to a replication setup, a replication topology where you have two or more than two Postgres nodes, or a streaming replication cluster, actually. And they are connected by logical replication between them. So yeah, it means that writes can send to multiple primary nodes while keeping them in sync by using logical replication. And it is designed to support active-active setups with some limitations that we are going to see later, but it supports. Also, well, distribute application and HA environments are support here. One important thing is it has native support, because here we are using a stream replication plus logical replication. So you don't need to enable any extension to be able to use it. You just need to configure both replication. And yeah, you will have it running. It's more complex than that, but yeah, basically you need to configure both replications, and yeah, that's it. And then just to set the correct expectations here, let's see what is not bidirectional replication. So it is not a synchronous multi-master replication, so no real time. You can configure streamer replication, sorry, to be synchronous, but not the logical one. So no real time. As you have many nodes that can accept write traffic, it's possible to have conflicts, and unfortunately Postgres doesn't resolve them automatically. Yeah, so you have to design or to configure your systems to avoid them. Otherwise the replication will stop, and you if you have any conflicts, so yeah, you will have a problem there. Or it will require manual tasks. Maybe not a problem, but yeah, you have to do things to resolve these conflicts. And also, well, it doesn't replicate DDL, alter, create index, and so on. So yeah, you have to apply them manually, and it have to be in the same order across the nodes or the primary nodes, and not eventually consistent by default. Yeah, the replication is asynchronous, so yeah, there can be lag and replication lag, and it can be possible that in-flight transactions are not visible on all the clusters. So yeah, you should keep that in mind. Now let's see what the feature solves for. Well, first, regional write availability. In a traditional setup, all writes go to a single primary node in one region, in one geographic region. So in applications running on other regions or data centers, you could have high latency. So you need a good network. You also have a potential downtime in case of failover or attacks, which is a problem, of course. With this, applications can write to a local primary node, and it will replicate data to other regions or data centers, and it will use logical replication for this. Then active architecture. Well, this is related to the previous one. Here you can write in more than one primary node in this architecture. So you can distribute operations and load. Also, in case of failure, you don't need to wait for this failover to finish, or for reconfiguring replicas. You can continue writing in your cluster as usual. Um, Finally, for upgrades or migrations, this has been a problem for Postgres for a long time, the upgrades and migrations. Here you can upgrade one cluster, and you can still use in another one. Yeah, because you can replicate data between different versions, so it helps here. And now about pros and cons of this solution, this bidirectional replication setup topology. About pros, we have you have multi-region write access. This allows local writes in distributed environments. This helps on reducing latency, for example. And you also have high availability. It combines streaming replication for local failover if you need to do that, and logical replication for the synchronization between the clusters. It also distributes write traffic across different clusters, a streaming replication cluster, or across primary nodes. You can perform zero downtime upgrades. Yeah, we already mentioned this because logical replication allows the replication between different versions. And it is a table level replication, so it is more flexible replication. You don't need to replicate all the data here. You can choose what tables to replicate. And well, that is about pros, and about cons. Postgres doesn't resolve write conflicts automatically. That is important to mention. Logical replication doesn't replicate DDL. The schema changes, so it will require manual task to apply them. And you have to to apply all these changes in all the primary nodes. There is also a potential replication lag, as logical replication is asynchronous, so changes may not immediately visible across the clusters, which can be a problem in some cases. And also, as we mentioned earlier, there is not conflict resolution here. So the applications has to handle conflicts, or you should implement a strategy or configuration to avoid them. And finally, it is a more complex topology. It is not just a streaming replication with a couple of nodes. It combines streaming with logical replication. So you have to manage both configuration, both technologies or methods. But during this webinar, we will see how to use ClusterControl to make it easier, let's say. Now, the question is when to use it and when not to use it. First, when to use it? When users or services are globally distributed, and if each region needs low latency write access, here is good to have this. Then if multiple systems or services need to write to the database in different regions at the same time. Also, if you need to upgrade Postgres without downtime, as we mentioned, it helps because you can replicate from different versions. And if each region or data center should work in case of failure, with the option to sync changes later, that is when to use it. There are more cases, but just to mention some of them. Now, when not to use it, in case the same rows or tables are modified concurrently across region, and if you cannot isolate writes, yes, this is a problem for logical replication. Then, in case of the conflict detection and resolution are difficult or risky for your system, sometimes it's hard to manage it from the application. So in that case, it's not recommended to use it until you have a way to handle these conflicts. Also, if you frequently run schema changes, in that case, you have to run them manually in all the nodes, in all the primary nodes. So it could be a time-consuming task, this. Also, when your application can't tolerate replication lag, if you need your system to be in sync all the time, you have logical replication here, so that could be a problem. And finally, if you have a standard, a normal primary standby setup, if that is enough for you, if it works, and you don't have this like a requirement or something, it is not necessary to make it more complex, let's say. So if you don't need it, you just can continue using the standard primary standby setup. Now let's see implementation basics for this solution, bidirectional replication. First, about requirements. The environment is recommend to use Postgres 10 or higher. I will say 14 or higher because logical replication is more stable or mature, let's say, in this version. But yeah, the minimum version is 10. Then operating system, any modern Linux version, it's okay. Ubuntu 20.04 or higher, Red Hat, Debian. And yeah, about hardware, CPU minimum 2 CPUs. Also at least 4 GB of RAM per node. About the storage, SSD or something with good IOPS in case of intensive workloads. Then networking, low latency internode communication. This is good for the replication here. And properly configured firewall and the authentication for also for the replication. These are the basic requirements. And here is the basic topology for this solution. This is just an example for bidirectional replication with 2 streaming replication clusters with primary nodes and read-only replicas. And they are connected by logical replication, as you can see in the image. This is the basic implementation. So here you need one primary node per cluster. And you could add standby nodes in a streaming replication, one or more than one. Or you can just keep the primary node only, but it's recommended to have at least one standby node per cluster. I will say two, but the minimum is one. So in case of failure, you can promote it and continue using the cluster. Then here we have logical replication between the streaming replication clusters to sync. So yeah, basically we have 2 streaming replication clusters connected by logical replication, and this is the basic topology. Now, if you want to implement this manually, you have to create both streaming and logical replication. So you have to install the software, configure the software, configure replication, and so on. So yeah, first after installing the software and configure this, you have to make sure logical replication is enabled in the cluster and configure some parameters. Then you need to create a logical replication user with the correct privilege, and you have to add this user to the pghba.conf. Yeah, to allow connecting to the nodes. And now you need to create publications on each primary node and subscription on each cluster to connect to these publications. And you have to do this from both cluster and two both cluster. So from cluster A to cluster B and from cluster B to cluster A, if we go back to this example. And one important thing here is when you create the subscription, make sure you set the origin in none. This is a parameter for the subscription. Because if you set it in any, that is another option, it will replicate all the changes. I mean, the local changes and the changes that it gets from another cluster. So you will have an infinite loop there, and you don't want to have this. This is a problem for sure. So yeah, that is important to mention. And finally, you have to make sure that everything is working correctly. You can run some commands to see if the replication is working, or you can just create a database or insert data and see if this was replicated to all the nodes in the same cluster and in other clusters. That's it. That is the faster or easiest test, let's say. And well, some considerations. We already mentioned some of them, but it's good to mention it again, just in case, to emphasize this. It is asynchronous only, so it is possible to have replication lag between the clusters that they are connected by logical replication. There is not built-in conflict resolution. You or your application should handle it for now. We are going to see why I say for now later. Logical replication doesn't replicate schema changes, so you have to apply these changes manually, and you have to do this in the same order in all the nodes, in all the primary nodes. Also, it's important to make sure that replication lag is monitored, and you can see when you have replication lag. Because as you are using logical replication, you want to make sure that the data is in sync. And also the wall management. You should configure wall file retention policy for archive and for wall files to prevent disk issues, these space issues, or replication issues. In case you can have too many or some wall file missing. And here we can see how it looks, how this implementation looks in ClusterControl. You can see all the status for all the nodes, for the clusters. You can see alarms. You can see the alarms here in the UI, or and you can receive this by email. You can also deploy this topology, this technology from here, from ClusterControl. But yeah, we will see this in some minutes during the demo. So what is next? The current version for Postgres is Postgres 17. The next major version is 18, and it will be released in September this year. And yeah, they are working on these features. This the one that you can see in the screen. They will add replication for generate columns. Now this is a problem because it's not replicate in logical replication. So yeah, they are going to add it in the next version. Also, they will add detection for more conflict types, also for logical replication. Inactive replication slots, yeah, you can deactivate automatically after a timeout. So right now you have to monitor the slots because yeah, otherwise you will have problems because wall file retention. And another thing is DDL replication. This is still under discussion, so I'm not sure if it will be added in the next major release. And the same for built-in conflict resolution, still under discussion. So yeah, let's see what can be added in the next release. And now let's see how cluster control can help on implementing and managing this topology, this bidirectional replication topology. First, in case you don't know the product, let's see what is cluster control. Well, it is a self-host platform where you can deploy, manage, monitor open source databases with you will have a centralized control and monitoring platform. Also, it can be integrated with tools like Terraform, Ansible, Slack, PagerDuty, and even more. You have the CLI. You can use the command line as well. And it has a user-friendly interface to make all these tasks, all these things easier and faster. The requirements for cluster control are at least 2 GB of RAM. I would recommend 4, but depends on the number of clusters that you are going to manage from cluster control. But yeah, the requirements are 2 GB and 2 CPUs. The same for CPUs. It depends on the number of clusters, but yeah, these are the minimum requirements. Um, this space, 40 GB, this is to store historical monitoring data and configurations. Cluster control can be integrated with cloud platforms like AWS, Google Cloud, Azure, and more platforms. You can store backups here, or you can integrate these platforms to deploy clusters. So for this, you will need to configure credentials in the integration section, but we will see this later. And about operating system, it supports many operating systems like Debian, Ubuntu, Red Hat, Rocky Linux, and more. So now let's see, yeah, a short demo. Let me stop sharing because I need to switch. Okay. Here is the cluster control UI. This is the home section. And here you can see this the bidirectional replication setup. But first, let's mention some sections here. Here in the cluster section, we will see an overview of the clusters. You can see different technologies, different clusters here. The status or the alarms for these clusters. You can also see the node section, the status for all the nodes, and here the alarms. If you go to the cluster section, you will see all your clusters. Here I have the bidirectional replication topology. To deploy this topology, this solution, you can go to deploy a cluster, create a database cluster, and you can choose the technology here. If you use logical, you can add, you can create this topology. But cluster control supports different technologies like Galera, MySQL, MongoDB, and more. Here you can choose a vendor. You can choose the open source, Postgres, or Enterprise DB, and the version here. And then you can specify a cluster name, or you can just leave this empty, and ClusterControl will create one name with the cluster ID. And you can use tags for this cluster. Then SSH credentials. This could be a root user or a sudo user, but it's not necessarily root. You can use a privileged user, but for this example, let's use root. And then you can choose here if you want ClusterControl to install the software and configure everything for you. Disable firewalls, Linux, AppArmor. Then the node configuration here, you can specify the database port and credentials. Let's put something just to continue. And the repositories, you can specify the repositories that you want to use, SSL encryption. And here, this is the each cluster that we have in the UI right now. These are streaming replications cluster 1 and cluster 2. And here, let me just put you can use a hostname or IP address. Here, ClusterControl will try to access the node to confirm that you can the connection is working. So you can use this node, and you can add more replica nodes for this streaming replication cluster. Let me put another node here. Okay, here I have two streaming replication. Well, not the streaming replication because I only have the primary node, but yeah, these are, if I add more replica nodes, these are streaming replication clusters. And you can enable extensions from here, PG Vector and PG Hit. You don't need to install this manually. ClusterControl will install the extension. And then you can review the settings here and finish. And this will create, after some minutes, this will create this topology. Here, the first one, as you can see here, you have both clusters inside the first one. This is the logical replication, the connection between the streaming replication clusters, where you can create publication and subscriptions. I have here already created both the publication from cluster A and cluster B. Let's say if we are using the same topology that we saw in the presentation. But you can create more publication and subscriptions here. And this is what I mentioned in the presentation about the origin. You should choose none here. And we have an explanation here, a warning, just to avoid this issue that I mentioned. But yeah, you can create publication and subscription for here. You can choose the cluster, the database, the name. You can include all the tables, or you can just choose tables to be replicated. And the same for subscription. You can choose the cluster. You can choose the publication from the list, the database, copy data. This will create an initial copy from the publication from the remote node, the remote cluster. And yeah, the subscription at here, you can enable or disable the subscriptions. And you can see the alarms related to the clusters here, and the shows that ClusterControl is running. And if we go back to the clusters section, you can also choose the specific streaming replication clusters, where you can see an overview of the cluster with some metrics, some graph here. And you can choose a cluster overview, system overview, if you want to monitor the operating system on some Postgres related metrics here. And you have different sections. You can go to the node section to perform actions on the nodes. You can, for example, you can promote a replica from here, or you can review the replica if needed. You can enable synchronous replication also from here. You can access the node. You can reboot. You can perform many actions from here. And you can also enable or disable auto recovery. This for the streaming replication cluster, if you have the auto recovery enabled, in case of your primary node fail, a ClusterControl will promote the replica node to primary. And if you have more replicas, it will reconfigure the rest of the replicas to connect to the new primary node. So you don't need to do anything, any manual task here. ClusterControl will recover your cluster. And you can also see the topology view here. You can monitor the performance for the cluster. You can use the advisors here, the agents, the query monitor agents, or you can see the connections, top queries. Then you can see the backups. Here you can create manual backups, or you can schedule backups. It can be, this can be done from here. You can choose the backup method. For Postgres, we have PG dump, PG base backup, PG full, PG bar rest, full differential incremental. You can choose the host here. And you can upload this backup to the cloud in the same backup process. This is not related to the replication, but yeah, it's good to have a backup policy in the cluster. And yeah, you can enable encryption, partial backups. You can store the backup in the ClusterControl server for a centralized administration, centralized backup controller, or you can store this in the node. And here, this is because I choose the upload backup to the cloud. This, if you enable this, ClusterControl will take the backup, will store the backup in the location that you say here, and the same backup, it will take this backup and will store the backup in the cloud. So you will have two copies of this backup, and yeah, that's it. You will have the backup created there. And yeah, I want to make this short. So yeah, you have the alarms, shops. These are the tasks that ClusterControl is running. Logs, you don't need to access the nodes. You can check the log files from here. The audit logs, reports. You can create an error report. If you have any issue, we will ask you for this to see what is happening. Manage, you can see configuration, settings. You can configure the email notification from here. Then I want to show you the integrations here. You can configure different integrations like Slack, PagerDuty, VictorOps. So yeah, you can receive notifications, or you can run commands from these tools to ClusterControl. And yeah, the cloud storage credentials. Here you can add the credentials for the cloud integration. Yeah, so yeah, basically here you have the topology that we saw in the presentation. And now let me stop sharing. Okay, can you see the presentation? I guess yes. Okay. So yeah, that was a short or not too short demo. So
It was good stuff. Thank you, Sebastian. So if the number of people who are still here, of those who started with us, is any indication, it looks like we got some good information out. Good tour of Postgres bidirectional replication, and also a nice thorough statement of cluster control. So thanks a lot. Alrighty, folks. Do we have any questions? Thank you for that, Derek. All right, I'll go into auctioneer mode. Joseph, thank you as well. Yes, so it looks like an operational question. The recording will be made available. I will send it out with a post production email for everyone. So no worries there, along with the deck. All right, going once, going twice, and we can move on from the Q&A to our final poll. Just 3 questions. And the poll is now launched. So we'll give about a minute for everyone to get in, because sometimes it's hard to find.
oh, we have a question from Alok. I will answer this. Is ClusterControl is part of Postgres software or is a separate one? No, ClusterControl is a separate product that deploys open source, or deploy or manage and monitoring the open source databases, different technologies, not only Postgres. And it has different versions or licenses. So yeah, you can check the website severalnines.com/pricing to see the different versions. There is a community version that is free with some limitations, but we have also different versions for this product. But yeah, the short answer is no. It's a separate product. It's not the same.
Yeah, apologies, Loco. You got lost in the shuffle there. Thanks, Sebastian. Thanks for snagging that fly. All right, and with that, I'm going to close the poll. Thank you, everyone. I'll share the results real quick while you're taking a gander at those. We can close out. So look, if you haven't already, we're going to probably run around a webinar a month. You know, we put out some decent content every month as well, whether that's a white paper, a few blog posts. We have a podcast called Sovereign DBAS Decoded. So if you haven't already, sign up to our newsletter. You can register for that in the footer of any page. Otherwise, you can get into it through the blog. As well, if you haven't had an opportunity, make sure you sign up and try ClusterControl. Take it for a spin for 30 days. No commitments, no credit card. You get the fully loaded version, enterprise version. And then you also get an opportunity to experience the support that we provide. So yeah, with that said, thank you, Sebastian, for your information. I enjoyed it. I think everyone here did as well. And thank you everyone for not only registering, but showing up and participating. Okay, have a nice day, everyone, and we'll see you around.
Thank you.